All right, let's go on to number 4. On vacation, you purchased a painting from a local artist for $2,000. Since the purchase, the artist has gained national attention, and the painting you purchased is now worth $5,000. Find the absolute and relative change in the value of the painting. Okay, so we have formulas for all that. Okay, we need to find the absolute change, which is just the compared value minus the reference value, and we need to find the relative change, which is absolute change divided by reference value. Okay, so all we have to identify is which is the reference value and which is the compared value. Okay, so let's see. Well, I think we would want to start with our reference value as the original cost of the painting. The current value is being compared to that, so this is going to be our compared value. Okay, so to find out our absolute change, and it's gone up in value, so we want to find the relative, it should be positive. So this is going to be 5,000 minus 2,000, which is $3,000. To find the relative change, I'm just going to use this absolute change, or you can just start over and do compared value minus reference value. But that's going to be 3,000 divided by the reference value, which is 2,000, which gives you 1.5. We want to change that to a percent. So it is now 150% more than the original cost. Okay. The original price of a generator is $800. It is on sale for 20% off the original price, and you have a coupon for an additional 15% off the sale price. This is where you have a shifting reference value. So it is going to be a two-step problem. Okay. So step 1 is going to be the 20% discount on the original price. Okay, so let's think of that. We need to find the price. So if we have a 20% discount, we're going to have to find out the percent less. So we're going to start out with the original price, which is going to be 100%. But then we're going to have to take out the 20%. So all I'm left with here is 100% minus 20%, whoops, which is 80%. So 80% of the original is the sale price, and I am abbreviating here. So this is 0.80 of 800, which becomes $640. Okay. All right, step 2 is a 15% discount on the sale price. So I'm going to have to use that value here. Okay, well, finding this, I'm going to follow the exact same steps. I may have to write over here because I wrote too big. Okay, so this is the sale price, and I'm taking away 15%. So 100% minus 15% is equal to 85%. So I'm looking for 85% of the sale price is the final price. So that's 0.85 times 640, which gives us a final price of $544. Okay, so what is the actual percent of the original price? Well, remember, the percent can just be a fraction. So we're going to take the final price divided by the original price, which becomes 544 divided by 800, which is 0.68 or 68%. Okay. Now we're moving into the 6D, I believe. All right, so we want to find the rate of inflation between 2003 and 2019. You will be given the consumer price index, so you don't have to worry about that. But just remember, the rate of inflation is just the relative change formula using consumer price index values. Okay, so let's look at this. Excuse me. So we want to compare the rate of inflation. So we're going to go from 2003 to 2019. So this is going to be my reference value, and this is going to be my compared value. And so the CPI in 2003 is 184, and the CPI in 2019 is 255.7. Okay, so I'm going to use the CPI in 2019 minus the CPI in 2003 divided by the CPI in 2003. So that's going to give us 255.7 minus 184 divided by 184, which is 0.3897. Excuse me, pay attention to rounding. Turn this into a percent, becomes 38.97%. And we had a discussion about rounding. If you have questions about how to round, be sure and go back and review that video from Unit 1. Okay, in 2000 a particular TV cost $300. What would be the equivalent cost in 2010? Yes, we know the prices have gone down, but if you were going to predict what the cost should have been, okay. All right, so we're going to start out, and I'm going to have my reference year is where we started at 2000, and my compared year is going to be 2020. We have a formula for this. We know that the price in the compared year is equal to the price in the reference year times the CPI in the compared year divided by the CPI in the reference year. And notice here, as I'm doing this, I'm going to put this over 1. This is what we want, which means we have to know all of these, and we do. Okay. The price in the reference year is $300. I'm going to put that over 1 since I'm multiplying fractions. And again, you will have the chart. The CPI in 2020 is 258.8. In the compared year, in the compared year, in the reference year, it's 172.2. Now, help to remember this formula. Okay, notice you can think of these almost as units. You have a reference year in the numerator, a reference year in the denominator, so you want to be able to cross those off and end up with the compared year. So now if you just do your multiplication and division on this, then you just end up with $450.87. Okay. In 2010, a teacher's salary was $35,000. In 2017, the same teacher earned $41,000. Did the teacher's earnings keep up with inflation? Okay, once again, this is a two-step process. We're going to use the same formula. This is all relative change. Okay. So the first one we're going to have to deal with is the relative change in salary. Okay, well, what do I know here? I know that we're going to be comparing 2010 to 2017, and we want to compare it to inflation. So that means this is going to be our reference value, and this is going to be our compared value. We're comparing the 41,000 to the 35. Okay, so we know that this is 41,000 minus 35,000, all divided by 35,000, which gives us 0.171 or 17.1%. Okay. Now the second part is we have to deal with the inflation. We need to find the rate of inflation. We're still going to use the relative change formula with CPIs. Our reference value is going to be 2010. Our compared value is 2017. So we're just going to have to look those up on the table. So the CPI in 2017 is 245.1. In 2010, it's 218.1 divided by our reference value, which is 218.1, which becomes 0.124 or 12.4%. So the answer to the question, did the teacher's earnings keep up with inflation? Yes. Salaries went up 17.1%. Rate of inflation went up 12.4%. So they are still ahead of the rate of inflation. Okay, so a new test has been developed to determine if somebody has lupus. The table shows the results. Okay, so we've got the disease. The people who have it, the people who don't have it. And then we have the test results. Those who tested positive and those who tested negative. Now, what I would do is, again, to kind of spend a little time and make sure I understand what's going on, I would label these. This is total test positive, and this is total test negative. This is total participants. Notice this is tested positive. It has nothing to do with whether or not they have lupus. These are tested negative. It doesn't matter if they have, it doesn't take that into account. Okay. This column is total with lupus. Again, it doesn't matter what their test results are. This is the total without lupus. Okay. Okay, so what percent of those who test positive actually have lupus? All right. So let's see here. What percent of those who test positive? Okay, so these are all the people who test positive. How many of those actually have lupus? So again, when we're doing a comparison like this to find a percent, we can just do it as a ratio. So, okay, 90 out of the 95 had lupus. If I do my calculations here, this becomes 0.947 or 94.7%. Okay. Notice that we're looking for out of those, this is what goes in the denominator. Okay. All right, what percent of those who do not have lupus? So we're looking at this column now. Test positive. So when I set up my ratio on this one, I'm looking at 5 out of 205. So what part of this actually had lupus? When I do that, I get 0.024 or 2.4%. Okay. All right, what percent of those tested? Okay, that's going to be our total participants. Okay. So now we want to know how many had lupus and tested negative. So two conditions: have lupus and test negative. So they have lupus and they test negative, so I'm looking for 10. So in my ratio, I'm looking for 10 out of the 305. And that becomes 0.033 or 3.3%. Okay, now asking for how accurate is the test, well, we want to know what percent of those tested got accurate results. Okay, so those tested, and then when we're looking at that, what we're looking at here is the accurate results. Remember, these are my accurate results here. So accurate results is going to be 90 plus 200, which is 290. So 290 out of the 305 got accurate results, which is 0.951 or 95.1%. All right, everybody. I don't think there's anything good on TV tonight, so you may as well watch this. Remember all the instructions for the test tomorrow, and good luck.